Question 2 is about the elements sodium to sulfur in period 3, reacting with oxygen to form oxides. Give the equation for sodium reacting in oxygen. So Na plus O2 is going to form Na2O. How do I know that it's Na2O? Well, sodium's in group 1, so we'll form 1 plus as it loses 1 electron. Oxygen's in group 6, so we'll gain 2 electrons, 2 minuses. So I'm going to need 2 Na pluses to balance with the 1 O2 minus. So Na2O, and then I'm going to need 2 in front of the Na2O to balance the 2 oxygens, and therefore I'm going to need 4 Na. Observation, so it will burn with a yellow flame, and this sodium oxide is going to be a white solid because it's not a transition metal, it's not got an incomplete 3D orbital, so it's a white solid. Phosphorus, so this time you've got to know the formula of phosphorus oxide as P4O10, and therefore you need 4 P's and 5 O's to balance. Observation, again a white solid. Or you could say burns with a white flame, either of those will do. Explain the increase in melting point from sodium oxide to magnesium oxide. Well, Na is in group 1, sodium's in group 1. These are ionic solids, so it'll form Na plus. Magnesium will be Mg2 plus, so sodium 1 plus, Mg2 plus, so magnesium is more ionic, and so it'll have a greater charge, stronger ionic bonding in Mg2 plus to the O2 minus, because Mg2 plus has got a larger charge. Explain why the melting point of the oxide of silicon is much higher than that of phosphorus for 3 marks. Well, silicon oxide forms a giant macromolecular structure, whereas phosphorus is a small molecular structure. So a giant covalent or macromolecular structure, a bit like diamond or graphite. P4O10 is molecular, so once you've got 4 P's and O10s, it doesn't get any larger than that. Those are single molecules then that are attracted to each other by van der Waals forces, whereas SiO2 is a giant covalent macromolecule with covalent bonds between all of the atoms in a large lattice. And so the bonds in SiO2 are much stronger than the intermolecular weak van der Waals forces in P4O10. The sample of the highest oxide of phosphorus was prepared in the lab. Describe the method for determining melting point. So you put a small amount in a melting point tube, and then you melt it. You heat it slowly at first. Well, you can say heat it slowly throughout, actually. You heat it slowly, especially near the melting point, the expected melting point. And then if the melting point agrees with the data book value, you know you've got a pure sample. It also melts sharply if it's pure as well.